today we're starting 14.2. So we're going to be focusing today about solving equations that involve a rational function. Remind me again, what's a rational function?
Is that like with non-real numbers?
Nope.
Any
real
function
numbers?
that can be defined by rational numbers.
Nope.
Fractions.
Getting closer.
Rational fraction. Any function written like P and Q are polynomials.
There you go.
14 lessons.
So it has, excuse me, let's focus. So a rational function is just one polynomial divided by another polynomial, right? So an equation, a rational equation, has at least one rational function in it. Ooh, excuse me. So, is this a rational equation?
Yeah.
Okay, where's the rational function part at it? Now, technically, those are rational as well, because you can write them over one, and one is a polynomial. But like, we usually think of it that way. Everybody's okay so far? A little tiny baby step. So the question is, what is going to be our technique to solve this? Well, the method we're going to use is called clearing fractions. So the idea when we clear fractions is we want to multiply both sides of the equation by the least amount so that when we're done, we have no more fractions. So if we take our current problem, that's the only fraction that we have, correct?
Yes.
So when we multiply both sides of this equation by something, we need 3 over x to not have a denominator on it anymore. Everybody's okay with that? What do we need to multiply both sides of this by so that there is no more denominator on 3 over x?
Are we going to do like a reciprocal type thing?
Well, if you do that, then you're going to make denominators on the other ones. Just x.
Yeah.
I don't know if I was going to say. I know. Dude, literally.
So we'll multiply both sides by x. And I notice that when I multiply x to 3x over x, when I multiply x to 3 over x, I get 3x over x. So the x's just cancel out.
Are we going to equal it to 0?
So now we need to get it to equal 0. Very good, because it's a polynomial. So we'll subtract 4x from both sides. And what kind of an equation are we left with?
Polynomial quadratic.
Polynomial is general, quadratic is more specific.
Hey, you laughed. She thought.
To solve a quadratic, what are some of the ways we can do that?
Plug it into your quadratic formula.
You could use the quadratic formula. You could do factoring. Those are our primary two. This one, which one would you prefer to do here?
You can do all factor.
I would try to factor this because the leading coefficient is 1. If it's factorable, it's going to be easy to do that. Does this one factor? Yes.
-1.
Very good. -3 times -1 gives me +3 and adds to give me -4. So these are our solutions, but we're not done. Why not? I have my values for x.
You have to plug it back into the original.
Yeah, why do we have to do that?
Get rid of that fraction.
Shh. Can we just, this side of the room, can we just try to focus a little bit? I know that you're all kind of like involved in this and it's really distracting for me. And I know that you guys didn't get to this last year, so I'm trying to go through like extremely slowly doing this because I know you haven't done it before. If you could help me out a little bit on that, I would appreciate it. Okay. So yeah, we do still need to check these. What's the reason we need to check them?
Make sure they're balanced with our x.
So here's kind of the big idea. The equation we ended up solving was actually quadratic, right? The domain for any quadratic function and any polynomial is all real numbers, right? The equation we're actually trying to solve, though, is this one, which is a rational function. The domain for a rational function can have holes in it, right? Where the asymptotes are, where the removable discontinuities are. What we have to make sure is that the solutions that we found aren't actually the location of an asymptote or the location of a removable discontinuity. The easiest way to do that is just to check. So all I'm going to do is plug 3 in for x. When I do that, I get 3 plus 3 over 3 is equal to 4. That's true. And when I do it with 1, I get 1 plus 3 over 1 is equal to 4. That works. Both of these are correct. Let's try another. Okay. So we have x minus 6 over x plus 1 equal to 0. Do I have a rational function here? Yeah, where is it? That's my rational. So I need to multiply both sides of this by something so that the x plus 1 in the denominator goes away. What should I multiply both sides of this by? It'll also be x plus 1. So multiply that to both sides. Sure. Is everybody okay? I can reduce my fraction now. And then I'll have to FOIL that out. Or not FOIL, distribute. What am I left with? Quadratic. How do you want to solve this one? That sounds good to me. How does this one factor? Very good. So my solution should be -3 and +2. Am I done?
No, I'm gonna check it out.
Still got to check. So if I go back to the original, let's see, -3 plus 1 is -2. 6 divided by -2 is -3. That is indeed true. If I do 2, two plus 1 is 3. 6 divided by 3 is 2. So both of those worked. I'd consider both of these solutions. Of course. Let's try this one. So we see that here we have 3 different rationals, right? That makes life a little bit harder, but that's okay. So what am I going to want to multiply to both sides to get rid of all of these denominators? Why do you say that?
The other two are factored in first.
Great.
Only knowledge.
So, Sophia noticed that x squared minus 4x plus 3 factors. It factors to x minus 1 times x minus 3. If I then multiply both sides of this by x minus 1 times x minus 3, everything is indeed going to cancel out. Right? And when we reduce, notice that all of our denominators go away. Distribute through. Combine some like terms and move everything onto one side. We have this What kind of an equation are we left with?
Quadratic.
Okay.
Formula.
You guys want to use the quadratic formula on this one? Why did you change your mind here?
Because the leading coefficient is 2.
Yeah, the leading coefficient is no longer 1, so if it's factorable, it's going to be a hassle. That's assuming that it's even factorable, right? Are all of these have to be factorable? No way. $25 plus 24 is 49, and the square root of 49 is 7. 7 plus 5 is 12, divided by 4 is 3. 5 minus 7 is negative 2, divided by 4 is negative 1/2. But are we done? Okay. Okay. How does that one look? I don't even have to go any further. I see a problem right now.
You got a 0.
As does this one. So that solution doesn't actually work. I don't know why I didn't write this way. Why didn't I write it this way, guys? Right? That would have made life way simpler. I'm going to change that up. Okay, so we plugged it in. Tell you a little tip here. Does that give me 0 denominator? Negative 1/2 minus 1? Is that 0? Who cares what it is? I'm just asking you, is it a 0?
No.
No. How about negative 1/2 minus 3? Is that 0?
No.
How about negative 1/2 minus 3?
No.
How about negative 1/2 minus 1? If none of those are 0, guess what? It's going to be fine.
Let's go.
So really, what does the check boil down to?
Just seeing if it's a solution or not.
Just going to see if it has a 0 in the denominator or not. That's all we're really looking for, is just to see if you get a 0 denominator. And if we look at the factored form, it's really pretty easy to do that, right? Oh, just as an aside, when we get one of these solutions that fails, we have a name for this. We call these guys extraneous solutions. So these solutions that we get but don't actually check out are called extraneous solutions. You're back. How was campus ministry? Did they give you snacks? Yeah. All right. Let's do this one. All right. First step. Well, how do you know that's going to be the case? No. Definitely not. Because the denominator is not multiplied together. But you're right, Sophia. That is what we need to multiply both sides by. So multiplied everything out. Now what?
Cancel them out.
Okay. Oops. That was supposed to be 2.5. Everybody good? Okay, so it's going to give us 0 equals, and then 2.5x plus 0.5x is 3x. Now subtract it over. Negative 2.5x and negative 1.5x give me negative 4x, so I'll add that over. Well, I left this over here, right? And moved the other stuff over. Now, how do you solve something like this? So what are the two numbers that multiply to give me negative or positive 4 and add to give me negative 3? Okay, there aren't two numbers, so we have to use quadratic formula.
Sorry, but like I guarantee you, Well, don't take it out. It's okay, it doesn't matter. Just ask him if you have an issue. Nobody else knows.
9 minus 16 is -7. What's the square root of -7?
The root of negative is I. 3 plus or minus I.
Yes, I. And what is this going to mean?
Oh, the imaginary universe. Just sounds like funny.
Since we got an imaginary solution there, that means that no real solution. Graphically, what does that mean?
We got some asymptotes.
That means if I move this all onto one side and graph it, it should never cross the x-axis. Let's just demonstrate that. Oops. I'm in the wrong mode here, folks.
No, yeah.
And then I'm going to subtract this piece over to the other side, so it's all just equal to 0. I'm just demonstrating to you guys what no real solutions means. Oops, I have my axes off. So if we look at this,
So what does that mean, guys? Asymptote.
None passes.
do you see it ever cross the x-axis?
No.
Nope.
That's
That's why it's, again, no real solutions is telling us that there's no values of x that make this thing equal to 0, i.e. there's no x-intercepts.
yeah.
I did it.
I just got mad.
I did it.
Shh.
You have 1 minute to lunch.
So you just want to save this one till after?
Yeah. I
Okay.
think I'm losing my
In here, I don't think it's freezing. It's like 72.
Give me a coffee.
That's tardy, buddy.
Hey, bro, watch out for the floor.
God, no one's in that house or taking their
Thanks. All right. So we were getting ready to start this example before lunch, so we're just going to circle back to this. So we have a story problem situation. Bill wants to fence off a rectangular pasture. His pasture must be 500 square feet. What is the smallest amount of fencing that Bill will need? So what shape is, let's start by drawing a picture. What shape is our pasture going to be?
Rectangle.
Okay. So we'll use X for like the width and Y for the length. Okay. What's the area of a rectangle got to be? Okay. So the area for that rectangle needs to be 500 feet. How do I calculate the area? Length times width, or in this case, X times Y. Right? When it asks for the smallest amount of fencing that Bill will need, what is that describing?
The perimeter.
The perimeter. Very good. How do I calculate the perimeter for a rectangle?
Width times height.
That's the area.
Oh, good job.
What is the perimeter again? Just describe what that means in words.
The outer area.
The distance around. So it'd be Y plus X plus Y plus X. So 2X plus 2Y. Everybody's okay with this? So what I'm going to do then, or what we're going to do, we're going to take our perimeter equation. The problem with this, though, is how many variables are in this? 3, right? We have P, we have X, and we have Y. Everybody agree with that? I need just 2 equations to find a minimum, because I'm going to graph this in my calculator and use the minimum command. So I need to eliminate either the X or the Y. It doesn't really matter which one. Which one am I going to choose to eliminate?
Y.
The Y. So what am I going to use to eliminate the Y? That X times Y is equal to 500. Or in other words, if I divide both sides by X, that Y is equal to 500 over X. That's all I need now. So I'm going to just go into my calculator and just kind of type this in the way it looks on my sheet of paper. Everybody okay with this? I'm going to set my window though. So X is representing this length, right? For the rectangle. So what's a good minimum value for that X? What's the shortest that side could be? 0, right? Can't be negative because it's a length. The Y, well, I don't know how long that can be. I'm just going to pick, say, like 50 or something. That seems probably big enough. And the P is going to be the perimeter, right? That's going to be like my Y variable. What's the smallest the perimeter could be? 0, right? If we're just adding up side lengths, that certainly can't be negative. And I don't know how big that perimeter will be. Let's just say like, 200 or something. It's probably big enough. 50s. Okay, and we'll hit graph. So here's my function. So I'm interested in the minimum, which it looks like it's right around here. How do I find that with my calculator? Second trace. Choose that minimum command. And then it asks for left bound, so I'm going to go move my cursor somewhere left of where that minimum is. I guess the minimum's around here, so that looks left of it. I'll press enter. Now it asks for right bound, so I'll just move my cursor somewhere to the right of it. So then I guess my minimum is over here. That looks right of it. And then I guess it doesn't matter. So there's my minimum, 2236. And the perimeter would be 89.44. So we need 89.44 feet of fence. Guess we should say at least. What you guys think? Not too bad, right? We can do this. All right. So at this point, you guys should be able to do like 25 to 34. But let's do a couple of these together, eh? Well, apparently I just transported myself to Canada, huh? It happens. We're so close to the border.
Yeah, honestly.
I'm surprised it doesn't happen to me more often, you know? Don't you know? All right. So, I'm just going to pick a couple of these evens. We'll do a couple, one or two of these together. What do you guys say?
Right there with you.
Okay.
So if you say that deserve my grade? No, because I always found out. Their body kind of. No, but that's very
So I just grabbed a couple of these even ones. Why do you suppose I picked the even ones?
Because we have the audience.
Yeah, because you have the odd answers already. Let's do ourselves a favor. Take out whatever you like to do your homework in. Okay, notebook, OneNote, scrap sheet of paper, the back of a matchbook, some napkin you had at lunch, whatever you're going to write on. Maybe your spare t-shirt for gym later, whatever. Find something to write on. Your hand. Okay. Let's take, I don't know, a couple minutes here, and then we'll try number 28, and we'll go through it together. Okay. We'll say 5 minutes or something. We'll go through 28 together.
Yep.
Let's do it, right?
Yeah.
Let the learning begin. Just so you know, I'm going to be calling on random people to ask me what to do.
Yep.
So if you're usually like, I sit here and twiddle my thumbs, you may want to think otherwise because you might get embarrassed. Not that being embarrassed is a bad thing, but sometimes that's a good motivator for a teenager.
We're doing the first one. Yep.
28, yep. Give you guys about 5 minutes here, and then we'll start going through it together. It's not a bad first idea. There's not a lot of factoring to do on this first one, though. It doesn't hurt to check, for sure.
Okay, I'm first.
Oh, were we doing this by ourselves? And then...
Yeah, sure.
Oh,
Yeah, what did you say?
I thought we were gonna do this. Okay, wait. I need to get this one. I was waiting.
Yeah, so don't even start with video buffoonery if I've ever seen.
We got something exotic over here.
And then you're like, I said, I'm gonna figure it out.
Just a quick, what are we trying to do? I'm gonna pick up.
Yep, solve for x.
Okay.
Same thing we were doing in the homework or in the notes stuff. You know?
Yes, sir.
I know you had that lunch break and then you ate all your knowledge out of your brains.
Yeah, I know. So
Bad case of the bread head.
Alright, no, I was gonna ask. Oh, okay. Okay.
Okay, I know.
I might tell me sleep.
I did get that far. Like 29.
Doesn't mean it's wrong. Just because you got something weird. That could happen.
Really? No.
Run.
Yeah, get him! Oh, I'm getting somewhere. Okay, I'm sorry. Does anybody want to?
I'm really excited that you're excited.
So am I. What do you think?
Might be looking a little goofy.
No, I think actually, read five.
Why did you say that?
Okay, Liz, it's okay.
Dream fast.
That was not. That's not what she meant. That was so over dramatized. Dramatized.
What's Miss Beverage got over there?
Why did so many?
Can I at least get all of it?
No.
Man.
No. Wait, I'm confused. I'm confused. I wasn't really sure.
No.
All right, ladies and gentlemen. That's been 5 minutes.
That's you.
All right.
Wait. I want to see. Oh my god.
Ooh, do you want to be my first call?
She's up first.
Mr. Cool, I answer questions in class. Do not call him.
It's not a punishment. And here's the thing. If eventually almost everybody's going to get called on, wouldn't you want to be the first? Because the steps at the beginning, you have the best chance of being a... No, I'm going to ask you about things to do.
We're all gonna be
Sure. All right. Yes, Bree. What did you do first?
I multiplied it by 3.
Multiplied both sides by 3?
Yeah.
Is that what we want to do first? Not quite.
not quite.
Yeah, so Alexis, x plus 3 is what I would have used.
Oh, that's bad.
Now, Bree, why would we want x plus 3 instead of 3?
Oh, so you cancel out the.
Yeah, we're trying to get rid of the denominator, so we need to use the entire denominator.
Okay.
Okay.
I got that one.
Bella, what do I get when I multiply both sides by x plus 3?
Oh, I did it a different way. So I did 8 over x plus 3 minus x equals 0. What?
Okay.
I think I did it wrong. Oh!
So that would have been 5 though, right? We're 8
Oh, yeah,
over?
5 over x plus 3. I just subtracted because all the other examples that we did over here, it always was equal to 0.
Okay, well that's still fine. Eventually you still would have multiplied both sides by x plus 3, right?
Right, I did.
Okay, and what? I'm really excited. Okay, and what happens when we do that?
So the 5 cancels out, or the x plus 3 cancels out, so x plus 3 times 5 minus x equals 0.
Be x times x plus 3, right?
Right, and those. Oh, okay.
Is everybody okay to hear?
Yeah.
Okay. Caden, what happens next?
I'm not gonna lie, I got to the x2 plus 3x minus 5 equals 0, that's all I got.
Okay, so great, you're doing fine. What would we do at this step though?
Don't you gotta distribute x?
Okay, we can do that for sure.
Then I got x squared.
And how about on the other side?
Then you gotta cancel out x plus 3 equals 5.
Awesome.
Did you surprise yourself?
Great. Okay. Julissa, you want to go? You had your hand up earlier. Any ideas what to do from here? No? Brett.
You subtract the 5 to get all equals 0.
Excellent.
And then you do the quadratic form.
Great. And
Bomb drop.
okay, so we're going to do the quadratic formula. Let's see, Olivia,
Where are we at?
what's the quadratic formula?
X equals -3 plus or minus root 3 squared minus 4 times 12.
Times 1 times.
-5.
Okay.
And then over 2 times 1.
Okay. All right. So when we simplify this down, we get 9 plus 20.
Exactly what I have.
And can we simplify the square root of 29?
No.
You're
crying.
Yeah, did it.
Okay.
Oh, and that's the final one.
Well, are we done?
No, you gotta check.
Yeah. So Bloom's right. We do have to check.
It's gonna be wicked.
What do we need to check?
You gotta plug it back in.
See if this does that make a 0 denominator? Well, of course not, right? Because that's not -3. That's what I would have to add 3 to make a 0.
Yeah, so we're good.
We're good. But we have to check. All right. Next one. We'll take 7 minutes on this one. It'll be a little bit lengthier, most likely. If I haven't called on you yet, be ready.
I was so down.
Well, you start off being like, oh no, no, no.
That's
So,
what I thought was wrong without.
so hey, look, it's okay for it to be wrong. It's not a big deal, right?
Yep.
You're gonna make mistakes. It's your first time doing it. Nobody expects it to be perfect right away. It's okay to make mistakes as long as we learn from them, right? That's how we get better.
This one be wicked.
Maybe, probably not.
This one will be wicked.
I have no idea that part.
So do you have to do?
Oh.
I'm trying to figure that out now too. So you multiply
Wait, are we doing this
x
next one
and
too?
x plus 1. Because
Yes.
you know, no, I'm lost in stuff. So think. I don't have a clue where it's going.
Figure it out. I thought it was X bar. Oh yeah, it's X plus 1. Then X plus 3. No, it's fine.
I just multiply that all.
Get rid of your denominator.
Oh, wait, you can just do this. Gotcha. You multiply that. So you're gonna multiply by x, and then in another parentheses, x plus 1. Yeah, that's right. You call it up. X minus 3. No, yeah, x.
Oh yeah, so how do you do that? Oh yeah. Oh yeah. I would the personality? Yeah. I think that was crazy. Oh, is it good?
Hey, focus on your math. I know personality test is really interesting. I get it. You can tell me all about it in like 10 minutes.
Go outside, guys. What do you mean, dude?
Oh my god.
Yes.
Okay, -5 x equals 0.
Mine's
All right.
How?
Yes, x equals 0. Yeah, I would eat your foot off. What were you eating?
Mr. Foolish, what would happen if someone got all of their tendons sliced at the same time?
Probably lay really still for a long time.
I know.
You
Oh my
might,
gosh, I did this one.
you'd probably die actually. I think you'd need your tendons for your diaphragm to work.
Would you die instantly?
So I don't know if you'd be able to breathe afterwards.
Why would you cut someone's leg off? You die right there.
Well, did you put a tourniquet on them?
No, I just cut it off. I just ripped it off.
They'd probably either bleed out or die of shock within a couple minutes.
Shot.
He didn't just
Yeah.
eat my foot off.
Yeah, because he also threatened to cut all my tendons, bro.
What do you know?
And what are you gonna do about it? You won't get the little move.
You won't have a foot, dude. You really lost. You don't have a foot.
You'll die.
You would die of shock. If they just ate your foot.
You guys are weird.
Yeah, yeah, they are weird. Oh my god.
Not for yours, it's a weird one. Yeah, x equals 0.
I got that too!
Well, I got, wait.
Wait, oh my gosh, if that's right, I'm gonna
Well,
freak
I
out.
checked that.
Because I'm redoing 28 over here.
I got
because
x
messed
is
it up.
not equal to 0 and x is not equal to 1, but x
It's
is
so
not.
great.
Take that off.
People actually.
I didn't get that either.
You enjoy it.
No, not at all.
What did you say?
What you got on this?
What'd you get?
I got X
You're
here.
joking.
I got X.
Says 330.
Yeah,
Woo! I got that
I got
too.
395.
395.
Yeah.
I can't get 395. I come with you.
No, I got 130.
You weigh 395.
That's what he got.
What?
What?
You're in a whole different conversation, Bree.
Oh, sorry.
Yeah, please stay out of our conversation.
Oh. He's sad.
I got 5.
You're sorry.
I can be if you want me to be.
Oh my gosh.
Dang, coming after you.
You're really locked your door. Breathe. See what you did there. Oh. I see what you did. No,
What we see?
nah, you don't see the bigger picture.
Oh, my bad, dude. I'm not the big picture, bro. That's the whole landscape. How much weight on this body is there? Maybe 495.
I wonder what somebody call him that. Yeah, okay then. Yeah, the two.
Dude, I got 195, dude.
You kinda just prayed.
You gotta take away the hand.
Sophia.
Yes, that.
Steven says he's gonna eat everyone's feet.
Ew.
I just didn't say that.
Ew.
Matt said,
Okay, where do you start, bro?
All right.
Let's do this thing.
Let's do this thing. All right. Francesco, what did you do first?
I times by x and x plus 1.
I like that.
Oh, I wanted that.
Yep.
Now, the reason that works is because x squared or plus x factors to x times x plus 1, right? Okay. Sophia, what now?
I then distributed
Okay. So what would we write then?
I did.
What's the first fraction?
I did x, x plus 1, x minus 3. Then I put the yep.
Over.
Over x.
Great. Boyd, what's the next fraction?
I cannot tell you.
We're off the top of that.
So we're doing that one.
-3.
I'm not sure.
Okay. Matt, can you tell me the next fraction? Housey.
What do you do?
Nice fraction.
Let's see what I wrote.
You doing the second one? It's
The second
x,
fraction.
x plus 1. 3.
No.
Then you gotta cancel out the x plus 1.
I don't know what I did, but it wasn't.
Okay. Caden, what do we write here?
Don't you guys just do the x, then the x plus 1 or whatever,
Mm-hmm.
then the 3.
I'm going to put the 3 there. Is that okay?
Yeah, that's cool.
Okay.
Then you gotta
We're not there.
Yep, we'll cancel on the next step.
Oh, okay. And then I did.
All right, Housey, you
I
tell me.
did plus. Okay, well. And I have. 3x.
Okay, 3x.
I should have 3 now. X plus 1.
Yes.
Over x squared. Oh.
Okay,
no.
and I'll write, instead of writing as x squared plus x, I'm going to write as x times x plus 1.
Yeah, that's what I have. Oh, I don't have an x.
And then it's still equal to 0, right?
Yes.
Okay. Henry, what do I do next?
you did it, you just
I think that's wrong, because I did just times by x plus 1.
Okay.
I assume you divide
Right, you reduce each fraction. Great. What can I reduce from the first fraction?
x.
Yes? From the second fraction? Yes. And from the last one? Perfect. All right. So after this, we have that stuff left, right? What do next one? Great. So we'll foil. Yep, that puppy out. Ruff, ruff, ruff. It's a mean dog right there. Okay. Maddie, what next?
So what I got was x squared minus 5x equals 0.
Good. So we combine like terms. Great. That's what you should get. And then Luke, what do I do next? Okay, Sadeki,
Add 5x.
I wouldn't do that
I wouldn't need it.
because it's already a polynomial that's equal to 0. That's what we want to solve that.
X times x minus 5.
Yeah, so Matt's right. You got to factor. So we can take a greatest common factor of x out.
Yep.
And now we can just apply the zero product property and set each of those factors equal to 0.
Now we're getting somewhere.
Now we're cooking with gas, right?
Now we're going again.
All right. Are we done, though?
Yes.
Okay.
Well,
Who haven't we called? Emma. How do I check these? We just did it today.
Dude, don't put me in
Okay. So if I'm plugging 0 back into the beginning, is that okay?
No,
not at all.
Why not?
strange because
Everything will be undefined. Only
We don't want undefined.
That would give me a 0 denominator, right? If I plug in there.
Five.
What about plugging 5 in? Is that going to be okay?
Yeah.
They're gonna be
Oh,
cool.
that's what it's gonna be. Yeah.
So we have one solution,
Touching.
5. Francesco?
Equals 0, divide out.
Well, we have to solve the original equation here,
Oh.
right? So you're right. When we solve the polynomial, yes, that polynomial solution is 0. But we're solving that to find this rational equation. Right? So we always have to go back to the very, very beginning. Maddie,
What did you plug in for check-in?
we plugged 0 into the original, and we got a 0 denominator, so we discarded that one. Then we plugged the 5 into the original, and didn't get any 0 denominators, so that one's okay. All right. Last one. It's the story problem. Sure. But I'm calling on you first.
Hey, I win.
Sure. So if you don't remember from geometry,
I struggled in doing
That first jumped out of my mind.
okay, well that's the volume for a cylinder.
Looks about right.
And we probably also need the surface area.
Oh, that's the worst one. Yeah, I'm right around there with you. I got an 80 here and there.
Oh yeah, I got 180.
Yeah, I got one. I was like, wow.
Zach got a 42 on
Stop it, let's stop lying. That's not wrong.
Armenians.
That was.
Means you guys just need like a minute to just duke it out here.
Should we just fence it out of there?
If you can get the right answer,
Right, now get the right.
if you get the right answer, you guys can have a duel to the
Let's
death.
wrap it out, let's wrap it out. Alrighty then. Alright.
I'm stuck at square one. How do you go backwards?
I want to say it one more time. One more time.
Oh, we're almost out of time here, aren't we?
Oh, we have places.
Okay, what do we start with?
Put it to 60 and it's 60 equals 5.
So plug 60 into my volume formula and then solve for either H or R. Obviously H is going to be the easier one to solve for. That was my choice. So then I take my surface area equation and plug in my value for H. At this point, it's calculator time. Yeah, just find the minimum value. I already wrote it down, remember?
5 to 34. Yeah, that's it. We have a lab too.
There's my minimum.
Good job.
Oh, come on here.
What's the new Wi-Fi?
Left bound,
Where's the break room?
right bound, guess. The break room?
Yeah.
I'm guessing that's
That's
their,
the one with the couches,
like,
right?
yeah, like across from the admissions office.
Are we allowed to leave this before?
Yeah, you guys should hit it.
Thank you.
Bye. Bye. Thanks, guys.
Bye.